So now we're going to delve down into the core of the whole of this Statistics 2 module. The hypothesis testing, all of that binomial and that Poisson, everything you have done comes down to these few moments. You know, if you're a keen student of things like psychology or economics or the sciences, you've probably come across hypothesis testing because this is at the core of any rigorous discipline. Anything where you've got some actual data that's actually tested to try and prove a point, hypothesis testing is at the very heart of it. It is a massively important of actual, not just mathematics, pretty much the whole way the world works right now. So, here we go. So basically there are 5 key steps to hypothesis testing from our perspective. Firstly, establish a null and alternate hypothesis. We'll go over those, what that means in a second. Then you just need to decide on a significance level, again, coming up. Then collect suitable data that is random and independent. So a good sampling technique is really important there. Then conduct a test, and you're going to interpret the results of your test in relation to what you're looking at in the first place. So let's talk about what makes a null and alternate hypothesis. So, let's get some more paper here a second. So a null hypothesis, I have a shorthand for this, which is H with a little 0. Okay, this is what we assume starting off is correct. So we assume this unless that our test that we do proves us otherwise, proves that this is wrong. Unless, okay, proved otherwise. If we prove this to be wrong, we need a backup scenario in place. And your backup scenario is the alternate hypothesis. And this we refer to as H1, your alternate hypothesis. Okay, so this tells us about the test if HO is wrong. So when we accept, so if we tell we're going to reject this one, we accept this second one instead. Here's our first one, is all about a student on a test possibly cheating. So, a student takes a multiple choice test as part of their course. On this test, there are 20 questions, 4 possible answers. Unfortunately, our dear student has, for some unknown reason, missed a large amount of lesson time and couldn't possibly know the syllabus or anything about it. But they get 10 correct on the test. Later on, it emerges as claimed that this student may have cheated. What is a chance that this student may have cheated on the test? So first of all, we'd establish our null and alternate hypotheses. Now, I've already written these out. It's probably worth thinking about, before we go too far into this, is the distribution we're looking at here. So we've got a fixed number of trials, N, and there's a probability P. So P is going to be 0.25. There's a 1 in 4 chance that someone could randomly guess that question correctly. And N is 20. There's 20 questions on the test. Now, got that one? Okay, found it. Yes, so our null hypothesis. Okay, we establish a null and alternate first. Our null hypothesis is basically that we're assuming that they didn't cheat. Okay, that the test wasn't totally fair, didn't cheat. So in that scenario, we can assume that, so HO, the null hypothesis, that the chance of them getting any one question right is exactly 0.25. So You might think, how is that a hypothesis? We just write the numerical version of this, that we're assuming that they didn't cheat as a 0.25 chance of any one answer being correct. However, if they did cheat, then they'd know a bit more than they should do. In which case, the chance of them being correct on a particular question is going to be more than 0.25 because they've got some extra information to help them out. So we actually write in your work as a statistician, you just write the HO, it would be P equals 0.25, and H1, the alternate. If we prove this wrong, we've got to accept, in fact, with no revision, they must have cheated. You are, of course, assuming there was no revision going on. We do need to define what P is, and P here is given the probability that the student guesses correctly. So they have no background knowledge, just guess correctly, they get it right. If it's exactly a quarter chance, because it's randomly guess, and bigger than that if they've probably cheated. Now, we're going to take the significance level at 5%. You don't have to decide this, you will be told this. But here's what it means. So, deciding our significance level is step 2. So the significant, I'm going to draw it like a normal distribution. I know it's not, it's kind of force of habit, but to help try and explain it. So if you've got distribution, here's your 5% mark. This is like under the null hypothesis. Under that hypothesis, so assuming she doesn't cheat, what's the chance that she would get 10 or more correct? If normally there's a less than 5% chance that she'll get it correct just randomly guessing, we've got to assume they probably didn't cheat. But if the chance of getting 10 or more correct by randomly guessing is more than 5%, i.e. is in this side, we can assume that they probably did cheat, because it's quite unlikely that it got 10 or more correct. Now I am saying 10 or more, because I know the student got 10 correct, so probability of X, you might think equals 10. But think of it this way, you're not trying to catch the one student. But what's the chance that anyone could possibly randomly guess and get 10, 11, 12, 13, 14 correct? So we're actually testing what's the chance that anyone could get 10 or more correct on the test without cheating. And you always look at some inequalities never equals something exactly. Because I think about it the other way, if, for example, it's you and you're cheating on a test, now you could get exactly 10 right. But we're going to say if you got 11 right, that you weren't cheating. But if you got 10 right, you are cheating. Doesn't really make sense. Surely if you are cheating and get 10, 11 or 12 right, you'll equally be cheating if you've got 13 or 14 or 15 right. You're probably more likely to be cheating if you got more than 10 right. So we're always looking at like inequalities going on here. So the 5% level, we now have to test it. So I've already defined earlier, so that's done for us already. We're given the data, we've got all the information we need. We identified it's already binomial. 20 people, 0.25. This is like under the, we're assuming this is correct at the moment. So the probability that you could get 10 or more right without cheating. Remember with binomial and those sort of things, looking at, 10, 11, 12, 9, 8, 10 or more is the same as 9 or less. So this is going to be 1 minus the probability of x is less than or equal to 9, which you have tables for. So that's 1 minus 0.9861, which is 0.0139. So under normal conditions, there'll be a 1.39% chance that you get 10 or more questions correct. So we talk about somewhere that this person is saying, hang on, there's a 1.39% chance you could get that score or better on a test by randomly guessing without cheating. Therefore, we can say, and this is a bit where now you have to interpret the results in relation to original question. We would say, there is evidence to reject the null hypothesis H0 and accept H1 that the student cheated. Now, a few things to note here. First of all, I did not actually say she did cheat. I said there is evidence to suggest that was the case. Okay, we can't definitively say they could have been flukily got 10 right, even there's a really small chance of that happening. They could have done it. So we can't actually say you are definitely cheating. What we can say is there's evidence from what we have seen to suggest there is a chance they were cheating. And the other thing to note is that we've used the phrase student cheated because that's in the question. We are referring to it in the context it was given to us. We're answering our problem.